Locomotive trains have been a big part of the development of our world since they were invented in the early 1800s, and are unique because you can actually see the gear system that powers the train from the outside as it runs. This type of gear is called a valve gear system. The valve gear system is used in steam engines because the mechanism controls both the inlet and exhaust valves and allows continuous pressure to be maintained by use of cranks and levers rather than cams and gears like in an internal combustion engine. The valve gear on this locomotive is a type of wall-shirt valve gear. The components include the control lever, the reach rod, lifting arm, lifting link, radius rod, combination lever, union link, crosshead, main rod, side rod, fly crank rod, and expansion rod. We can see here how all these parts move together. The control lever, reach rod, lifting arm, lift and link, and radius rod all move to determine the speed of the train by controlling the speed of the valve movement. The piston rod, main rod, and side rod create a slider crank mechanism to drive the wheel rotation. The rest of the gear connects these two driving movements smoothly and maintains the speed of the mechanism. There are many different ways you can represent the wall-shirt valve gear kinematically. Initially, the kinematic looks like this, with 18 links, 23 1 degree of freedom joints, and 1 2 degree of freedom joints. From the mobility equation, we get a mobility of -17, meaning that the mechanism is overconstrained. Since we know the mechanism can move and is not locked, this must be an inaccurate representation. Because the wheels are attached to the ground and the position of the side rod perfectly defines the position of all three wheels, the wheels don't need to be included in the kinematic diagram. This alternate kinematic representation, with 15 links, 18 1 degree of freedom joints, and 1 2 degrees of freedom joint, has a mobility of -10 and is still overconstrained. Further simplifying the mechanism, we realize that since all three wheels move together, the entire side rod does not need to be included, but simply the joint it is attached to. We can change the joint to be a pin-in slot joint with 2 degrees of freedom that travels in a circle of some radius on the ground. The mobility is still overconstrained at -4. Since there are two drivers in the mechanism, the piston and the control lever, logically the mobility should be 2. We cannot achieve this mobility because there exists a special linkage system made by these links. Like with the delta and parallel linkage systems, the special geometry of these links means that the mobility equation does not sufficiently describe the movement of the mechanism.